So hello everyone. In the last session, we have started the current and electricity, and we have seen some basics of class 10th, and we have also discussed about the basically the resistance in the last session. We have solved the different examples and see the variation of length and seen the variation of area, and I have also given you the one example. So let us see the what is the solution for this. Yeah, I hope this is the question. If you see this, in this case, the current is going like this. Correct. Even if you see properly, you will understand in this case the length is also not changing and the area is also not changing. Both are constant. So it is a direct answer. That is, what is R? R will be equal to rho. What is the length? Length is H, and what is area? That is pi p square minus square. Simple. That is the area. So this is the easiest case I have given you. So I hope now you are clear with how to calculate the resistance, that if whether it is a length variation or area variation. Clear? So now in today's class we are proceeding to the basic core of the chapter now. Now we are going to start the core of the chapter. Okay. So let us start. See, if you see the type of material, I have in the electrostatics also I have different. I have discussed about the type of materials. Here, if you see the type of material on the basis of conductivity, type of materials, if you remember, we have divided into three types. What are those? That is conductors, semiconductors, and insulators. Basically, in this chapter, we are not going to talk about insulator because in insulator the current is always zero. So why there is a need to talk if the current is zero? Because it is all about current and electricity, and current is zero, so there is a no talk about insulator. We have to discuss about two types of material here, that is conductor and second is semiconductor. Second is semiconductor. Basically in semiconductor also we are going to discuss, but there here in this chapter the discussion is only about 2-3 lines. There is not more than that we are going to discuss in semi. There is a separate chapter semiconductor physics that we will discuss, okay, where we will discuss everything about the semiconductor. If you remember the formula of resistance, what is the formula of resistance we have? The formula of resistance that you remember, it is 2 ml upon n e square a into tau, where I told you what is n. N is the number of electron density. Density means number of electron per unit volume, so that I am saying as number of electron density in a conductor, basically in a conductor. Okay, correct. A conductor or anything, any material, it is not always for conductor, any material. Okay, let me become more general. Okay, any type of material you are talking about, it doesn't. Okay, and tau we have talked about is a relaxation time. Relaxation time. What is exactly the relaxation time means? Suppose I am the electron. When the electric field is applied, I move to a some point. Basically, I am going to collide with another electron. That is obvious because it is a random motion. So I must collide between the there will be some collision will be happening. It means suppose this is a one electron, this is another electron. It will be collide with other electron also. But there is some time gap will be there during the two collisions, two successive collisions. For example, there is a one collision happen here and there is another collision happen here. So there will be some time gap is there now. That time gap is called as a relaxation time. It is a time between the two successive collision. Okay, so that is a time between the two successive collision. It is a time between two successive collision. That is a better understanding of relaxation time. Two successive collision. Successive collision. If you try to understand this, then you will get a better idea that it is a time it is a time between the two successive collision. Means suppose if I increase the temperature, basically we have to study what is going to be happen here. So if I am going to increase the temperature, first tell me what is going to be changed. Is this 2 is going to be changed? Answer is no. M is going to be changed? Answer is no. Mass of electron is a fixed quantity. Length is going to be changed? There will be some changes on the length. That is true, because if you have seen class 11, we have talked about the length is going to be increased by alpha L into delta T. But we are considering that the increase in length is almost negligible here, because the alpha of the linear coefficient of expansion is very small as compared to the other properties. So basically length variation we are taking as a constant. So length is not going to be changed. Whether the n is going to be changed? Answer is no. Why? Because the conductor has itself it has a lot of free electrons. So if you are going to increase the temperature, there will be more electron will produce? Answer is no. The number of electron will remain constant only. So there is no change in n also. E also there is no change. A also no change. What is the only change is going to be happened is tau. Tau is what? It is called as a relaxation time. If you are going to increase the temperature, you will see that the time between the two successive collision will reduce, means the collision is going to be occur more faster. Okay, there will be less time between the two. So what is going to be happen? The tau, my relaxation time, is going to be reduced. So as my relaxation time is going to be reduced, obviously my resistance is going to be increased. So in conductors, remember that in conductors, so, or you can say here tau is decreases with increase in temperature, so resistance increases. Now let us discuss here in semiconductor what is going to be happen. If you see in semiconductor, here with increasing the temperature, just I am telling you, obviously the tau will decrease, that is obvious, we got the reason. But what about n? Here n also increases. If you see in the denominator, one factor is increasing and one factor is decreasing. So how to do the conclusion regarding the resistance? Because one thing is increasing, one thing is decreasing. So which one is more dominant? That will give the major result. Whether n is dominant or tau is dominant. Answer is n is more dominant here. N is more dominant here, as here n is more dominant, and that we have find it experimentally. Okay, dominant then, and there is a reason for it that we will discuss in semiconductor physics. Then tau, so what is going to be happen? Obviously the resistance is going to be decreased. So that is what we have find. We have find that for conductors with increasing the temperature, the resistance is going to increase, and for semiconductor with increasing the temperature, the resistance is going to be decreased. Clear? Any doubt here? Note it down. Completed? Okay. So let us see. Now this is the only discussion you have to remember for semiconductor. Now we are going, whatever discussion we are going to do, that is only for the conductors. So let us start the discussion. Suppose I have a one conductor. Suppose I have some conductor. Okay, it is conductor. Correct. Suppose this is a conductor, it is given, and suppose initially at temperature, like at some temperature T, the resistivity of the conductor is rho. I have increases the temperature by delta T. Now T increases to T plus dt, means a small increase in their temperature, that is dt. So rho increases from rho to 0. Correct? And what we have find, we have seen, see, these are the experimental things. We have seen that the d rho with increase in the resistivity with temperature is directly proportional to the temperature. Correct? Directly proportional to the initial value of rho. So from here we have got a conclusion that my d rho, from here we got a conclusion that my d rho means increase in the resistivity is equal to alpha rho into dt, where what is alpha? Alpha is called as a, what is alpha? If you remember the linear expansion of coefficient in the length, it is a linear expansion of coefficient in the length. Here it is called as a coefficient of thermal resistance. There we have a coefficient of linear expansion. Here we have a coefficient of thermal resistance. This is called as a coefficient of, sorry, coefficient of thermal resistance. This is called as a coefficient of thermal resistance. Clear? And its value will be almost between 10 to the power minus 4 to 10 to the power some minus 3, minus 2, like that. You will get the value in this range. It is a very small thing basically. So that is the thing you are getting. Okay. So basically this is observed. So I can say from here, what I can say one thing, that is, what I can say, that my d rho is equal to rho into alpha into dt. So from here I can say my d rho, that is my d rho by rho into alpha into dt. Now integrate from here. This is my t initial and this is my t final. Similarly, this is my rho initial and this is my rho final. So from here what you will get, ln rho final by rho initial is equal to, what is this value, alpha into, or you can write it like this, because alpha can be function of temperature, no? Alpha can be function of the, we don't know about this thing. So from here what we have got, we got as rho f is equal to rho I e to the power integration Ti into Tf into alpha dt. I will tell you what you have to remember. Just note down whatever I am writing, just note it down. I will give you the conclusion, that what you have to remember for the exam point of view. That I will tell you. Okay. That is not a big issue. That I will tell you, because you can't remember lot of things, lot of subjects. Not only physics is there. Okay. So this is the expression we have got, and this expression is valid everywhere. This is valid everywhere. Means when my alpha is a function of temperature, correct, and when my alpha is a function of temperature and alpha dt is very large, or you can say when my alpha, this is valid, basically the condition, it is valid everywhere. Basically where we are going to use this equation, I will give in the conclusion. No need to write it here, otherwise it will be confusing. Just we got this first expression, this you have to not remember. I will give you the, I am saying I will give you. Now do you know the expansion of e to the power x? What is the expansion of e to the power x? What is the expansion of e to the power x? It is equal to 1 plus x upon 1 factorial plus x square upon 2 factorial, like that, correct? If I put it here, what I will get, rho final is equal to rho initial into 1 plus this thing t initial plus t final into alpha into dt plus t initial to t final into alpha into dt whole square divided by 2 factorial, like that, and so on. Basically I told you that is my alpha value will be almost in the range of, it will come out to minus 10 to the power minus 3 or 10 to the power minus 4, like that. It will be somewhere like this. So I can say my higher degree terms will be almost 0. I can say like that, my higher degree terms will be almost 0. These values will be very small, so I can neglect it. So from here I get my another thing formula, that is rho final is equal to rho initial into 1 plus integration Ti into Tf into alpha into dt. So this is our one equation. We have another equation that we got from this derivation. Correct? Any doubt there? So this is another equation you have got, that is rho final is equal to rho initial 1 plus Ti into Tf into alpha dt. Correct? Okay. So this is our equation 2 we have got. Okay. Now let us go to another page. So what we have got? We have got a equation. We have got a equation. What is the equation we have got? That is rho final. Rho final means resistivity at temperature, some final temperature or resistivity at temperature T is equal to rho initial 1 plus integration of Ti into Tf into alpha into dt. Now suppose, now let alpha is constant. If alpha is constant, I can write this rho f is equal to rho initial into 1 plus this alpha I can take outside and I can integrate, so I will get T final minus T initial. Correct? So this is another one more important equation. Just note it down. I will give you the conclusion. Okay, that is another most important equation. Equation number 3. Correct? Now we know rho is equal to what? Rho is equal to how much? R into A divided by L. Just put everywhere. So what you will get? Rf is equal to Ri into 1 plus alpha Tf minus T initial. You can put in any equation. I am putting in this equation. You can put in all the equations. Where there is a rho f, you can replace it by rho I. Correct? Where there is a rho f, you can replace it by rho I. No doubt. So this is the 4th equation we have got. Just note it down. Note it down all equation. I am going to give you the conclusion. What is basically the conclusion? Just note it down all the expression. What we have got till now. Completed? So what is the conclusion? What is the conclusion we have? See, the conclusion is very simple. Whatever the equation I am writing in term of rho, the same equation can be written in the term of R also. That is okay. In which place I have to apply which equation? See, the correct equation or the everywhere valid equation, the equation which is valid everywhere, that is this equation. So remember this equation, rho final is equal to rho initial e to the power integration of T initial T final alpha dt. This equation is valid everywhere in all the case. So basically where we have to use this equation, this is my first equation which I have. Correct? This equation you have to use where alpha is not constant, first thing, and the integration of Ti into Tf into alpha dt is large. Like it is not a very small number like 0.1, 0.2 like that. It is some coming up to some 10, 12, 13, 14 like that. Then you use this formula. Second formula, this formula can be written in the same way. This formula can be written in the same way. This formula can be written into like that also. Rf is equal to whatever the formula in resistivity, the same formula can be broken into a resistance also by using this relation. So this can be written as e to the power integration of t initial into t final into alpha dt. Simple. So it is also the same. It is also exactly the same conditions. Everything are same for this formula. No change is there. They both are exactly same. Only that is a resistance, that is a resistivity. Second formula which you have to remember is this formula. That is rho final is equal to rho initial 1 plus alpha integration of Ti into Tf into dt. See, this formula is applicable when, what is the condition for this formula to be applicable? Let me write both them in. This formula, or I can say this formula, Rf is equal to Ri 1 plus integration Ti into Tf alpha dt. These two formula are valid when my alpha is not constant, but integration of Ti into Tf alpha dt is small, because we have neglected the higher order terms. It's very small. Then only we got this formula, na? That means this thing has to be very small. And the last case, what is the last case we have got? Do you remember what is the last case we have left? Can anyone tell me what is the last case? Okay, that is this thing. Then next case is last formula, that is rho f is equal to rho I 1 plus alpha delta t, and Rf is equal to Ri 1 plus alpha delta t. Correct? This is the final formula you have to remember. This is I am doing for NEET student. Generally for NEET student, a lot of questions come on this. Okay. Okay, this is valid when alpha is constant, means they will give you some value, and alpha is constant and alpha delta t is small. Correct? So this thing, these are the three formulas which you have to remember for solving the question. And I'm not going to solve such type of question. Basically, what is this? Suppose you want to I can give you that type of question. Suppose my alpha is given as some 10 to the power minus 4, something like that, and my temperature is going from 300 Kelvin to 200 Kelvin, and my my initial resistance is 20 ohms. So what is my final resistance? Everything is given, just put the value and get the answer. Here what can I do? I will make the alpha as a function of temperature, suppose 2T plus 3, then and moving the temperature from 10 degrees Celsius to 20 degrees Celsius. Just you have to put here and calculate and everything to you. Simple. There is nothing so much complex here or something very much complex. Just you have to simply apply the formulas and you will directly get the answer. This is the conclusion for you. You have to remember this. Okay. It is a conclusion. This is the whole conclusion of whatever we have discussed right now. I hope it is clear now. Any doubt is there? So basically this is what you have to remember for solving any questions regarding this concept. Note it down. So basically if you talk about the conductors, we have seen that with increase in temperature, basically the resistance is going to be increased. That we have seen. So if it is like that, so can I ask you, if it is like that, then for conductors, can you tell me what is going to be the alpha for the conductors? If it is like that, what is the alpha of the alpha? You know, na, that is a thermal. What is this? It is a coefficient of thermal resistance. Alpha for conductors. is going to be how much? Like it is what type? It is going to be a positive quantity. Similarly, alpha for what? Semiconductor. With increase in temperature, you have seen that the resistance is going to be decreased. So what is alpha for semiconductor? It is going to be negative. Then only with increase in temperature you will getting lower resistance. So here the alpha for semiconductor is negative and alpha for conductors is positive, and alpha for insulator is very high, very high value. Okay, it is a very high value if you will see. Clear? Note it down. Completed? Okay. As every institute so ask this question, I will also ask it. What is the question? Suppose there is a conductor and suppose the length of the conductor is L, area is A, okay, that is given. Now the length is become 2L here, and suppose its resistance is R, then what is the resistance of this R dash? Solution. Tell me, what is the resistance of this thing? I have increased the length, I have make it double. Then what is the final resistance? Simple thing is there. See, length is increased. Then what is remains same from here to here? When I am coming from here to here, what is the thing that is constant? Obviously, volume is constant. V initial, that is a class 8 concept. V initial is equal to V final. What is the initial volume? A into L. What is the final volume? A dash into 2L. So everything will cancel out. Sorry, no, not area. You will get A dash is equal to A by. So what is the initial resistance? R is equal to, that is rho L by A. What is the final resistance? R dash. Rho, what is the length? That is 2L. What is the area? That is A by 2. A dash, that is A by 2. So from here you will get 4 time of R. So what is the general concept is there? The general concept is very simple. If you try to understand the general, or you can say trick or whatever, nothing. You can say it's a concept, trick, whatever like that. It is state that if volume is constant, if volume is, remember that volume has to be constant. Volume is constant and length goes to n times of original length, means length has been increased from NL. So my resistance will become n square times of R. My R dash will become n square times of, suppose the length is L and now it is increased to NL, so my resistance will become n square R, and R means the original resistance. Clear? That is simple trick or whatever you can say. So see, if the length has become double, so my resistance has become 4 times n square, means 4 times of R. Simple. Okay, so if you want you can remember, but I don't take it as a trick. It's basically a concept. You can understand from here why it is called as a concept. Okay, clear? Any doubt? Okay, so till here anyone have any doubt regarding anything? So please tell me, because now we are going to start with the major portion of our chapter, that is a circuit theory, and we are going to discuss about the circuit theory. Basically that is a major part of our this chapter. No one have a doubt? Can I start? So before starting circuit theory, I hope you have remember all the concept which I told uh, in the first class about the basic concepts of class 10th. Okay, because in the when I am going to start circuit theory, we will solve only the question, and by the question we will learn about the concepts. Okay, because only the questions is going to help us in learning the concepts. So these are the concept we have seen. If you have remember, we have seen each and every point, not a single point we have missed. Okay, clear? So now we can start, I think so. Let's start. Give me 1 minute. Yeah. Okay. So let us start. So we are going to start our circuit theory from here. Treat it as a new chapter because it's a part of the chapter, but it is a separate a new chapter for you because it is going to be the very important for you because 90% of the question from this only. So what is circuit theory? Basically what we are going to do, we are going to take a circuit and we will try to, basically here I am going to help you in solving the circuit, that how you can solve any circuit in like very easiest manner and very fast way. Okay, so we will first start with a very basic. Okay, I'm not telling you directly KVL and KCL, that we will learn, but we will first start with very basic. Clear? So let us take some first example. Okay, let us take first example. The first example is very simple. Example number 1. Suppose this is 5 ohm and this is 10 volt battery. My question is, what is the current here? Okay, what is the current? Then how will you solve? Most of the people will apply V is equal to IR. I know you know V is equal to IR. No need to apply that V is equal to IR. Now you have to, that is okay, you can apply, but now you have to learn a concept how to solve any circuit. This is a class 10 circuit. So what is the approach I told you? You can take any point on the circuit equal to 0. Any point, the potential you can take equal to 0. So let me take this potential equal to 0. If this is 0, what is this potential will be? Because the potential difference is 10 volt and I told you the positive terminal is higher potential, negative terminal is 0. So let this potential is x. So I can say x minus 0 should be equal to 10. So from here my x value will be 10. That I explained you also, but I am not, in first question I am telling this thing. Other I am not going to tell this. You have to now do it by yourself because I have explained, I given complete one lecture on this explanation. So x is equal to 10 volt. So if this is 10, this will be also 10. This will be also 0 because in connecting wire there is no loss. So what is the current here? Because the potential difference is, current will flow from higher to lower potential and the potential difference is 10 minus 0 divided by 5. So what is the current here? 10 minus 0 divided by 5, that is 2 ampere. You have to do in this manner, then only you can solve all the questions. Okay, because it is an easy question, so it look like why there is a need to apply this method. But let us see whether it is helpful or not. So let us start with the first example. Okay, just note it down. Yeah, so the example is 2 ohm. Don't go on my drawing. Okay, my drawing is very bad. Just try to like treat it, make it like it is. Correct, 6 volt. Now find the current in each branch. All the question are same. You have to find current in each branch. Current in every branch. That is the only question in this class. Every branch. I want to know the current in every branch. That is my question in this whole session. Whatever the question I am writing. Okay. So what is the approach? How to solve? Just take 0 at any one point on the circuit. So where I will take? You can take anywhere. but try to take at that place where the solving the circuit is become more easier. So I'm taking here, okay, I'm taking 0 here. So if this is 0, this will be also 0, this will be also 0, correct? If this is 0, this will be, because I am going from lower to higher, from 8 volt, 8 volt, the difference should maintain 8 volt. Just remember, the difference should be this point and this point should be 8. If this is 0, this has to be 8, correct? If this is 8, this has to be also 8. If this is 8, now the difference should be 2 volt. The difference should be, if it is at 8, higher potential is 8, then it has to be something like that, so that difference will be 2 volts. So I will take it as 6, correct? Now you can see this resistance, that this potential is 6, this potential 0. So current will flow how much? 6 minus 0 divided by 2. So it is 3 ampere from here. Are you getting my point? 3 ampere from here it will flow. Similarly, let us come in here. This is 0, but here you can see my higher potential at 0 and the lower potential should be such like that the difference should be how much? How much is the difference? The difference should be plus 4 volt, or like 4 volt basically. So you can do, if you have a confusion, just take it as x. Higher minus lower should be 4 volt. So 0 minus x should be equal to 4 volt. So from there x you will get minus 4. That you can do. If you want, you can do like that also. So this is become how much? So this will be minus 4 volt. If this is minus 4, this is 8. So current will flow from higher to lower. That is true. So 8 minus 4 divided by 2. So what is the value? 12 divided by 2, that is 6 ampere. So now you can see 6 ampere is like 6 ampere from here, 3 ampere is going here, correct? Okay, now in this case, now this is 8, this potential is 8. Here we have to write a potential so that the difference is 6 volt. So what is this value? This value will be how much? 8. From 8 I have to make, difference should be 6. So what is this value? This value should be how much? So that the difference should be 6. So this 8, see, you have to write for higher terminal na? So just 8 plus 6. If you are writing for higher terminal, then you have to just add 8 plus 6, you will get 14. And suppose here let's see, here it is 0 and you have to write for lower terminal. So just take 0 and you subtract whatever the drop is given. 0 minus 4, so it is get minus 4 volt. That is a fast way of doing it. But if you don't, if you are taking x and then doing, that is also okay, no need of issue. But if you want to do it fast, just simply remember the thing. This point is 8 volt. I have to write the potential here. Now this potential, this terminal is at the positive terminal. So what you have to do, 8, whatever the value is, this 6, add it, you will get 14. So my answer is, so this potential should be 14. So this will be also 14. Now you can see that here, that 14 minus 0 divided by 2. In this branch, 14 minus 0 divided by 2, that is 7 ampere. So now you can understand from here, in this terminal the current is 7 ampere, correct? And obviously this 7 ampere will be coming from here only, correct or not? Alright, the 7 ampere will be coming from here only, na? Now 7 ampere is coming. Now you can see properly, you can understand now the things. See, try to understand. See, what I am saying, yeah. 7 ampere is coming from here. 6 ampere is coming from here. 7 is coming from here. 6 is coming from here. 7 plus 6 is coming from here. As charge is always conserved, means current is also, whatever the current will come, it will be, so 7 is coming from here, 6 is coming from here, so 13 will go here. 7 plus 6 equal to 13. That we have seen the property of current now. Now 13 is coming from here. Similarly, 2 ampere is coming from how much? 3 ampere is coming in this branch, 3 ampere. So 3 ampere will also go here. Now 13 is coming from here, 3 is coming from here. So what? How much it will go? It will go how much? So 16 ampere will go in this branch. Clear? Have you understand the concept? See, I have to explain you. That's why it is taking a time to solve it. Otherwise, it is a single line problem. What you have to do? First, note down the step. What are the step you have to do? First, you have to assume 0 at one point on the circuit, and that point you have to choose. Okay, try to take 0 as in such a way, at such point where you will get to solve the circuit in very easy way. Generally it is a below point. Okay, then after that try to write the potential of every point. Okay, after writing the potential, what you have to do? You have to simply apply V is equal to I into R. Then after that you calculate current, and then simple apply the basic idea that whatever the current is, like how that what we have learned here about current, that current direction is important, that we have seen na here in this lecture. in first lecture we have seen this thing. If you remember this property, this thing we have seen, that concept you apply and you can calculate. If 2 ampere is coming from here, 3 ampere is going here, that means 5 ampere is coming like from here. That is a normal calculation. Okay, so from there you can directly apply this thing and you can directly write the current. Are you getting my point? This is the first example I have taken. I hope you understand the thing. Let us do some more example, then it will be more clear to you. Okay, we will take a lot of examples. Okay, just try to follow the steps. Example number 2, correct? Let's go for example number 3. Okay, so suppose 2 ohm, this is 6 volt, 4 volt, or 3 volt, 2 volt, 10 volt, this is 2 volt, and suppose this is 4 volt. Okay, same question, you have to find I in all branches. How to solve this? Just note it down. Okay, so what is the way you have to do? Assume 0 at one point, any one point where you think. So let me take 0 here. Okay, so if this is 0, this is also 0. If this is 0, this will be also 0. 0, it is at higher potential, like this terminal is at higher potential, so 0 plus what is the value? 10 volt. So 0 plus 10 means this potential will be 10 volt. Similarly here, if it is 10, then this is 3 volt. Okay, this is 10. Now this is again at higher terminal, so 10 plus 3, that is 13 volt. Sorry, that is 13 volt, correct? If this is 0 and this is at higher potential again, this terminal at higher potential again, so 0 plus 4, so this is 4 volt. Okay, similarly 10 here. Okay, now this is 0. Now this is at lower potential because this terminal is positive terminal and this is at lower terminal. This terminal, this terminal is at lower one. So 0 minus 6, so this will become minus 6 volt. Clear? If it is lower, then you subtract this from the lower value, and if it is higher, then add this to the lower value. Okay, now this is at higher value, this value is 10, this terminal has positive terminal of the battery, and this is 10. So 10 plus 4, this means this will be 14 volt. Similarly, if this is 14, now similarly come to here, this is 0 and this terminal at the positive terminal of the battery, this value is 2, so 0 plus 2, so this terminal potential will be 2 volt, like that. Okay, now let us calculate. So in this, here it will be also 14 volt. So in this branch you will see how much current? 14 minus 2, higher to lower potential, so 14 minus 2 divided by 2, that is how much? That is 6 ampere, correct? Similarly here, come to here, in this branch also. So basically you can see for how much current is coming from here, that is 6 ampere is coming here. Now let's come to this branch. 13 minus 4, 13 minus 4 means how much? 13 minus 4 is how much? 13 minus 4 is how much? That is 9. 9 volt. Here in what will be the current? 13 minus 4 divided by 2, that is 4.5 ampere. So the 4.5 ampere will current from here, come from here, and it will be 4.5 ampere here. Okay. Now in this branch, see, this is higher potential, this is lower potential, so 10 plus 6, because it is minus 6, so 10 minus of minus 6 plus 6, so this will be 16. 16 means 8 ampere in this branch. How much is the current? 8 ampere current in this branch. So you can see now 8 ampere is coming from here, 4.5 ampere is coming from here, so how much current will go here? 12.5 ampere current, means 8 plus 4.5, It will be 12.5 ampere current will go to here. Now 6 is coming here, 12.5 is coming from here. So how much will it will go? 6 is coming from here, 12.5 is coming from here. So they will go up to 6 plus 12.5, that is 18.5 ampere here. Correct? Now 18.5 is coming from here, 18.5 is coming from here. How much current in this branch? See, 6 ampere is in this branch, obviously. So here also we have a 6 ampere because it is the same branch. Now in one branch the current will be same, it will not be different. 6 ampere is coming from here. Now from this branch 18.5 is coming, 6 ampere is going here, and 8 ampere is going here. Try to understand from this, or you can see 4.5 is coming from here, so 4.5 will be here also, 4.5 will be here also, because it is the same branch. Now in one branch the two current cannot flow, in one branch only one current will flow. So this is 4.5 ampere, correct? So we know the current in all the branches, if you can see. So if you know this method, it is very easy to calculate the current in this branch. What you have to simply do, 3 steps. First, take a 0 at any point on the circuit, then start writing the potential at every point. Okay, how to write the potential? If it is come to the battery, just see which terminal of the battery you have to write the potential, then simply you add that value. If it is positive terminal, then simply whatever the value you know, just add this value to the what is the potential difference of the battery. And if it is negative terminal of the battery, then whatever the value you know, then simply subtract the battery potential from the known value, then you will get the potential of that terminal. Like here it is 0, this potential we know it is a 6 volt. This terminal is this wire is connected to negative terminal of the battery. So what will be the potential? This value I know, just subtract the battery value, like battery potential, by this value. So 0 minus 6, 0 minus 6, so minus 6 volts. So that this voltage is minus 6 volt. That we can also do, or you can take x here and you can write higher minus lower. 0 minus 6 equal to, like 0 minus x equal to 6. So you will get x equal to minus 6. That is also you can do. So there are the multiple way. I have told you every method in the first class only, and that just we are doing the application and we try to increase our most practice and practice. Clear? I hope it is clear now. Let's take one more example. Suppose this is 2 ohm, this is 2 volt, this is 2 ohm, this is 8 volt, this is 10 volt, volt, 4 volt. Clear? This is the circuit. Same question. Find the current in all the branches. Okay. What you have to do? Simply take 0 at one point. Which point you will take 0? Just try to think. Use your brain. You have to use your brain. Which point is suitable if you take 0? 90% of the cases it will be below point only. So let me take this value as 0. If this is 0, this will be also 0. This is a 0, then see, this is 0 and this is positive, this is connected to the positive terminal, correct? So what you have to do? 0 plus 2, so this potential will be 2 volt, correct? Similarly here 0, that is also 0, but it is connected to the positive terminal of the battery, okay, this wire. So 0 plus 8, so this will be 8 volt, correct? Any doubt? This is 0, okay. Again here also, this is connected to positive terminal, this is 0, this is 0, so this value will be how much? 10 volt. 0 plus 10, so 10 volt. This will be also 10 volt. Now this will be also 10 volt. This will be also 10 volt, because it is connecting where no voltage drop will be there. Clear? Now this is 10 volt. Now you can see from this is 10 volt and this is connected to the negative terminal of the battery. So what you have to do? 10 minus 2. 10 minus 2. This will become 8 volt. Correct? Similarly here, this is 0. This is connected to the positive terminal of the battery. What you have to do? 0 plus 4, 0 plus 4. So this is 4 volt. Now you know the potential of across every resistance. Simply write the current. In this branch, current will flow from obviously higher potential to lower potential. So 10 minus 2 divided by 2. That is how much? 4 ampere. So the current is 4 ampere from here. Correct? Similarly, in this branch is 4 ampere current is coming. Now in this branch, current flow from higher to lower potential. So what is the current? 10 minus 8 divided by 2. That is 1 ampere. So current is 1 ampere in this branch. Correct? So current here is also 1 ampere in this branch. Now you can see 4 ampere is coming from here, 1 ampere is coming from here, 4 coming from here, 1 coming from, they will obviously go in this branch. 4 and 1 will add up and go in this branch. Correct? That is a common logic, common sense. Okay. 5 ampere is coming from here, 5 ampere is coming in this branch, also 5 ampere. Correct? Now come to this. This is 8 volt, this is 4 volt. So what is the current from in this? 8 minus 4 divided by 2 ohms. So what is the current? That is 2 ampere. So current is 2 ampere in this branch. So from here current is 2 ampere. Now 5 ampere is coming from here, 2 ampere is coming from here. 5 and 2 will come, both are coming together. So they will, like this, they will go and they will add up. Common sense. This will become 7 ampere. Correct? Is it clear to you how to write the current? Just take a look of this. I hope you understand how to basically, so in this class basically we have just started circuit theory, and I hope you understand why I am telling you to learn this method. What you have to do, simply you have to take the 0 at one point and start writing the potential out across all the resistance. For writing the resistance, I tell you the method also how to write the resistance. Either you can take X, or then you apply the higher potential minus lower potential is equal to potential drop of the battery, or you can just use the basic logic. Okay, that is the same logic we are using. And then after that we have solved some example. In the next session we will also see some more example on this. Okay, and we will try to proceed this circuit theory as further as possible. Okay, so till then, if you like this session, please like it, share it, subscribe it, and take care. Have a nice day. Thank you.